For the CmpRound screen, we will need to show the current rounded number, total number of rounds, the question and quiz options, and a button to send the answer and continue the game. We first delete the temporary label we added when we created the component, and we drag and drop an HTML renderer widget, and we use as the ID HTML render question. We should leave space for both sides in case we have long questions, so we get a large left and right padding, and we can now start editing the HTML code that will be rendered by the widget. Inside the editor, we will use standard HTML code that we can use to give the quiz some formatting. Blazedpath has an engine to use stencils called handlebars. It can be used to make logic operations, read parameters, and other useful operations. To access the received parameters, we use double curly braces inside the HTML code. The current parameters are going to be total rounds, current rounds, questions, and they are going to be sent to the widget through a blocky called setValue when we go into the Logic tab. Now let's use an options group widget that we are going to use to display the possible answers, and we are going to name it option group answers. And we will set up a padding on top, on the down, left and right. And we are going to also be going to use a border on the top and on the bottom. The data format is going to be key value, just like the topic selection. This will come in handy when we want to identify which was the selected option from the group. And now let's create a button. That we're going to call button send answer. We're going to give it a text, next, and we are going to have some large padding on the top. And finally, we are going to select the root container and select a large vertical separation value so that we have a bigger distance in between the elements. And on top of that, we are going to add a large padding on the top to add extra separation on the top side of the screen. This should be looking pretty good, so let's go over the logic for this screen. Before starting on the logic, we are going to create a couple of config parameters that we are going to use to define the number of milliseconds to wait for the result screen, one for the correct and another for incorrect answers. So let's create a config folder. and we create it the same way we did on the microservice. MS wait when correct answer with 1000 milliseconds. And MS wait when incorrect answer with 2000 milliseconds. Now for the logic of the CmpRound component, the very first thing we need to do here is to read the game ID passed from the previous screen, and we do it in a microservice API request to start a round and display all the information on the screen. So we are going to right click, create main_init event, and in here we are going to create a game ID variable, a game state variable that comes from the microservice when a round starts. And one last variable which is going to store all the list of pairs of the answer options for the options group widget. First, we need to read the game ID from the received model through a read model blocky. Now make a microservice request to start a round and obtain the game state to get all the information of the current quiz. We are going to create a list of key value pairs for the options group. The key of the answers, number 1 will be in 1, 2 for the second, and so on. So that when we select the third or fourth option, we get a 3 or a 4 as the user response key. All this information is going to be used to fill the HTML renderer question, and we are going to pass the current round, total round, and question through the setValue blocky. Now remember that these 3 keys are the ones we are going to end up setting and extracting through handlebars on the sites where the double curly brackets are present. It's important to note that these values are the same values passed with the setValue blocky. Now to load the values of the options group through the load blocky, we're going to be passing the list of key value pairs with the answers. Remember that if the user fails the answer, we are going to show a screen that shows the correct answer. That's why we're going to start with a list of all the possible answers in a model variable, so it can be accessed by another event or function at a later time. So on the model, we create an answers variable of type list, of tuple, of integer, and string. Now to store the answers list on this model variable, we are going to use the write model blocky. Before we continue with the Booton implementation, let's check if the HTML render is actually drawing correctly with the options from the round start. So we run the solution and we can see that yes, we do see a correct drawing of the current round, total round, the questions, and the different answers. Okay, now for this button logic, we will create two integer variables, one for the game ID taken from the model and another to store the user answer. So let's start. We'll read the game ID from the model and the user response from the options group. We do a validation that the user answer is not empty, and we show an alert if it is. Now to end the round, we do an end round API petition to the microservice with the user answer and the game ID. The petition's response will be stored in a variable of type end round response that will contain the score and end of game flag. We continue on using a function called showRoundResult that will handle the quiz results display and will require as an entry parameter the user response and the response from the microservice. And lastly, we will check if the game is over from the microservice response. And if it is over, we will navigate to the CMP endgame component. But if it's ongoing, we will navigate to a new instance of the same component to continue the game. In both cases, we are going to send the game ID to the starting model of the new component. Now let's see for the function we just talked about, the showRoundResult. Let's create it. Let's go to functions, right click, give the function a name, showRoundResult. And as we already discussed, it is going to have the user and microservices responses as the parameters. Let's store the correct answers on a variable again. And we do a check to see if it matches against the one from the microservice. We read the model of the previously stored answers and we get the text of the correct answer amongst all of the options. We are going to be using the findFirst function. We look for the first pair whose key coincides from the server answer. That's the response.correctAnswer. Since the result of the findFirst is a pair, we are going to compare against the key value using a bracket and a 1 for the index. This is to get the string from the pair. Now we navigate to the result component and we pass over the flag to see if the answer was correct and the actual correct answer. Finally, we will wait a certain amount of time depending if the answer was correct or not. We can do it with the config parameter. We read the value and we store it in the CmpRound result model. And with the sleep blocky, we will wait for the time in milliseconds we got from the config parameter. Finally, time for tests again. We are going to create a route and CmpRound result. Routing will be /round game result with hyphens. For the CMP endgame component, that's /endgame with a hyphen. First, let's try without selecting an answer. We can see the error. Next, we will select an answer and we can see the component that shows the correct answer for a while. And when the game is over, it should show us the game over screen. For this example, the correct answer is Aquarius, so the component should show the answer screen for 1 second. And it does. Now let's get an incorrect answer. And we can see that CmpRound result stays for 2 seconds and was clearly longer than the first answer, which was expected. So let's continue playing for a bit. And finally, we can see through our logic that our game is over. So it takes us to the CMP endgame component. That should be enough testing for the CmpRound component. So I'll see you in the next one.